Good morning, everyone, or it's already 11 it's 12 in Germany now. So, yeah, guten Tag and herzlich willkommen and good morning and you are welcome. So, we are now today for the talk of Professor Dafi. He's a professor at University Mohammed VI Polytechnic in Morocco. It's situated in not far from Marrakesh in Ben Guerir, in a place where there is also the Institute for Solar Energy. He's working, he's a geologist, very much concerned about materials, raw material in Morocco, resources, and he is graduated from École Nationale Supérieure des Mines de Rabat. It's very well known, and University Qadi Iyad as well. He also got a certificate, so he visited or he was enrolled in Colorado School of Mine, and he got certificate regarding phosphate mining. Master from the HEC Paris in geopolitics and geoeconomic of emerging Africa. He has long-standing interest in diverse technical expertise in mining sectors. He visited and worked in several countries. He also served in many places and he delivered lectures, highly engaged in geological science, as I said, and at professional at UMCs and other places. He's recognized by several international and national organizations. He is certified professional geologist at the American Institute of Professional Geology. So there are many qualifications. You can visit our webpage. You can visit our Instagram. You can visit Facebook, LinkedIn. You find a lot of information what we injected there about Professor Daafi. He's regular member of the European Geoscience Union, and he's licensed person by Moroccan Ministry of Energy. So he's an expert in one word. He's the expert in Morocco for the geology and everything. Geology is very important, and maybe at the end I will say some words in Arabic. But let's give him the floor to talk about where he is working, himself, and his topic. Thank you for coming today to give this talk, Professor Youssef Daafi. Thank you for being member of the virtual learning university, and I just want to say to audience that you are going to give talks, lectures, syllabus, so course in this virtual learning university for free. Thank you very much. We are a non-profit organization to give talk to help students, and not only to help him in talk, but also if they have questions. We will have in our web page a place where it's called the talking to experts. So anytime they can ask for any questions regarding science and technique, etc. Okay, I will leave the system to give you the floor. Thank you very much, and go ahead.
Thank you very
much. The floor is yours.
Thank you very much, Professor Nawi. So I will try to share my screen. Can you see my screen, please?
Yes.
Okay, great. So good morning. Assalamu alaikum wa rahmatullah. I hope that you are doing well in this moment of uncertainty and that God protect you and your family. So I'm very happy to be with you this morning to talk and share with you the history of geology and geological exploration. But I would like to thank Professor Nawi and congratulate him for his efforts and his energy and nationalism. He is a man of value who puts his knowledge at the disposal of the society, and it is very appreciated. So I would like also to thank my colleagues and friends of VLU for their effort and the opportunity they gave me to share my experience around the geology. So as Mr. Nawi said, so my name is Youssef Daafi. I'm geologist engineer. At the beginning of my career, I worked for the managing group company in Morocco, which extract the fluoride in the Hammam mine. And on 2006, I joined OCP, exactly in Yusufia city, where I was in charge of geology department. And since 3 years ago, I joined the EM6P, where I take charge of management of the AMTTPA, which means Accelerated Mining Technology Transfer Platform for Africa, and where we work with a great team on 6 programs. The first one is around the artisanal and small mining scale, and where we have currently several projects in Morocco, and also we are asked to work with some brothers in Africa, and also we have a second program which is around the talent factory, and the third one it's around the preservation of mining heritage, because as you know, that's in Morocco we live in what we geologists call the geologist paradise, and we're trying now to valorize this heritage. And we have also the living lab, experimental mine, and currently we manage the first living lab in Africa, which call it Benguerir experimental mine, and we try currently to create another in Senegal and another around the gold, and a third one around the bauxite in Guinea. The fifth program, it's around the mining consortium. We're trying to have the mining operator in Africa in order to work together on some challenges, some mining challenges. And the last one is the expertise and consulting. Here we're trying to have a group of experts, African experts, to work together in some particular challenges in mining industry. So I would like to remind you some rules for the smooth running of this conference that I want it will be interactive, and you make sure that your microphone is switched off. And if you want to ask a question or share a comment, you have to use the raise hand. Mr. Salim, he will help me on that. Of course, you can cut me off if you see that I speak Chinese, because this is a geology and a lot of many people don't understand some technical words. And you should know that's the important thing for me is to understand the information that I will share with you. Okay, so feel free to use the language that suits you to speak with me. Il pourra être français and بالعربية أيضا, and also in English if you want. So, Professor Nawi asked me yesterday to make a quick presentation of my syllabus of the course that I will have the honor to lead very soon. And the syllabus of my course, it will be around the strategic raw material for renewable energy. And as you know, the shift to low carbon energy system will imply massive changes in the raw materials requirements due to the deployment of the technologies. For example, rare earth elements such as neodymium, dysprosium, and praseodymium are key ingredients of permanent magnets used in high performance with wind turbines. And we have also borates, gallium, germanium, indium, and silicon metals which are needed in solar photovoltaic and robotics and also the digital technology. We take also the example of batteries which employs some materials such as cobalt and natural graphite, which are also required in 3D printing and digital technology. We have also platinum, which is used as a catalyst in fuel cells and in digital applications, for example, for hard disk drives. Overall, the renewable sector requires many raw materials ranging from very high to low supply risk. My course will focus on the importance of these materials in the technological development of renewable energy. its resources and reserves, production, demand, and supply. So the main objective or the entities will have fundamental understanding of the mine life cycle, and we'll trying to talk about this mine life cycle during my talk, and also the main critical materials, their market analysis, the price and the price volatility, the supply from for primary materials and the supply from secondary materials, or what we call it the recycling. And the PLOs, the program learning outcomes, will be around 3 points. An ability at the end of my course, the entities will have an ability to develop and conduct appropriate experimentation, analysis, and interpret data, and use scientific judgment to draw conclusions. The second point, this is also very important, an ability to acquire and apply new knowledge as needed using appropriate learning strategies. And at the last and not the least, and the least and not last, so an ability to understand the impact of strategic raw materials in societal and environmental contexts and demonstrate the knowledge and need for sustainable development. Let's move now to the talk. So the presentation will be organized around 4 points. The first one is introduction, where we will see together some definition. And after we will see the phosphatogenesis, or the genesis of phosphate, or origin of phosphorite. And we will see together the criteria of the main Moroccan phosphate deposits. And at the end, we will take 2 slides to define to give you the standard definition of mineral resources and the reserves. Let's go. My first question is, what is geology? In order to know your background around the geology. So you can use raise hand. I have need 2 answers. What is geology? This is a question for non-geologists, please. Dr. Salim, because I don't see the screen of Zoom, if you can help me for the person who they raise hand.
Yes, I'm with you, checking everything.
Thank you. Let's go, guys. Anyone who raised hand? Okay, let's go. The geology, it's come from ancient Greek, which means G, earth, and logia, or this is a study of this course. So it's the science which deal with the physical structure and substance of the earth, their history, the processes which act on them, and the future of evolution. So the geologist is the scientist who studies the solid, liquid, and gaseous matter that constitutes the Earth and other terrestrial planets, as well as the processes that shape them. So the geologists usually study geology out of backgrounds in physics, chemistry, biology, mathematics, and we can define some disciplines in under the umbrella of geology in general, and we can find geochemistry. This is the application of chemistry in geology to understand the components of the rocks and the minerals. We have geophysics, which is the methods indirect methods that we use in exploration, in geological exploration. Paleontology, this is the study of fossils. Petrology, the study of petroleum and the gas. The metallurgy, which is my specialty, and this is the genesis of the metals. And hydrogeology, the study of underground water. Okay, so let's move to the definition of the mine. Are there anyone who can ask us the definition of the mine? What is mine? Anyone of you can define what is mine? Okay, let's go. The mine is a large excavation made in the earth from which to extract metallic ore like coal, precious stone, salt, or other metals. And we have 2 kinds of mines: the open pit that we can see in the picture in your right. We have here the copper mine in Chile, which is extracted currently by Codelco, and phosphate mines, which are in Morocco. The second type is the underground mine, when we have to extract the metals. in the underground. Sometimes we can go until 100 meters in deep. Okay. So what is the mine life cycle? The mine life cycle, it's the mine, also the mine is like any creature in the life. You should know that. It has a beginning and the end. This is called the mine life cycle. With the integrated development of the society, we started to talk about the sustainability vision of the mine, even if the mine contains the existable substance. And this mine life cycle starts by the exploration, okay, geological exploration, until the post-closure. We passed by design and development, the construction of the infrastructure of the mine, the production of the ore, and the closing of the mine. And after, we have to manage the post-closing. And by using the pillar of sustainability, which are social, environmental, and economic. Let's move now to the different kinds or type of the phosphate deposits. So the various phosphate minerals present in phosphate rock have diverse origin and chemical and physical properties. So the phosphorus content of or grade, we can call it the grade of phosphate rocks, is commonly reported as phosphorus pentoxide, P2O5. The principal phosphates minerals in PR or phosphate rock are calcium phosphates, mainly apatite. Pure fluorapatite contains something like 42% P2O5, and the mineral what we call francolites. Look, we have three major types of phosphate resources are being mined currently in the world. The first and the biggest one is sedimentary marine phosphate deposits, the igneous phosphate deposits, and the biogenic, or we can call it also the guano bergs or island deposits. So I give you here some definition that's come from Brettels and Gear in 1994, which say that the term of phosphate rock refers to rocks containing phosphates minerals, usually apatite, which can be commercially exploited either directly or after processing for commercial applications. In the next slide, I show here the map. You can see the dots, green, red, and blue, which mention the location of the phosphate mines around the world. And as you can see, that's approximately 75% of the world's phosphate resources are won from sedimentary marine phosphate rock deposits. And we have some 15 to 20% from igneous and the weathered deposits. And only 1 to 2% here that we can find here in the red color, 1 to 2% from biogenic resources, largely birds and the bat guano accumulation. We all don't know to understand more each kind of the phosphates. And we started by guano deposits. So this is igneous intrusive alkali rocks, particularly carbonatite complex and the associated contact metamorphic rocks. It provides about 15 to 20% of the world phosphate, usually fluorapatite. And this kind of deposits are formed from alkaline igneous rocks such as nephelinic syenite, carbonatite, and sand associated. So the phosphates is in this case contained within magmatic apatite, monazite, or other rare earth phosphates. And this deposits or this igneous phosphate rock concentrates are produced from deposits that are mainly exploited in Russia. The example of the picture that I give in your right in Khibini deposits. And also we can find some mines in Brazil, Finland, and in Zimbabwe. So the igneous phosphates ores are often low in grade, in rock, less than 5% P2O5, but can be upgraded to high grade products by using gravimetry, for example, and we go from 5% to 35% or over than 40% P2O5. Because there are just some crystal I can show you here. I have an example. I don't know if you can see this kind. I have this mineral. This is apatite. That's not come from Russia. This is a Moroccan one. but where I check from Emil, and I will talk about that area in my slides. Okay, so let's move now to the second kind of the phosphates. This is a guano deposits. And these are old and or fossil deposits of bird and bat excreta. And the guano deposits from birds are not mostly commonly found on ocean islands, especially abundant like some South Pacific islands. And and the guano deposits from bats are found in a large cave system. So and you can find it in the cave like this and like this also. So accumulation of birds and mammals excrements have also provided important source of phosphate rock. And this kind of deposits on small ocean island, for example, we can find it in Nauru and Christmas Island, were once major source of phosphate, but are now declining in importance or have ceased production. At these localities, bird excrement has formed thick accumulation of calcium phosphate or guano due to the reaction of the organic wastes with with underlying limestone rocks. Let's move now to the third one, which is the sedimentary deposits. So the sedimentary marine phosphate deposits occur on every continent and range in age from Precambrian to recent. And we have currently the Volga River, which bring some 6,000 tons each year into the Caspian Sea. And about 80% of phosphate rock used commercially is obtained from marine sedimentary deposits, what we can call it also phosphorites. And phosphorite beds consist of grains, pellets, or fragments, as you can see here in the picture. So this deposit typically show extensive reworking, secondary enrichment, and replacement shallow ocean areas, and continental shelves commonly have a thick accumulation of phosphorus-rich organic debris. Let's see now some types of sedimentary phosphates, and we will start by the first one, what we call it phosphate noodles. These are spherical, as you can see in the picture, spherical concentration that are randomly distributed along the floor of continental shelves. Most phosphorite grains are sand size, although particles greater than 2 millimeter may be present, and this large grain referred to as nodule. As you can see, there are the nodule which we extract here in Nigeria. And can range up to several tens of centimeters in size, that we can see here. The second one is the bioclastic phosphates or bun beds. The bun beds are bedded phosphates deposits that contain concentrations of small skeletal particles and coprolites. Some also contain invertebrate fossils, like brachiopods, and become more enriched in P2O5. So bioclastic phosphates can also be cemented by phosphate minerals. It's what we can see here. So we have the phosphates which cement the minerals. And here we have the different layers that come from Morocco. The different layer of phosphate. Here we will talk about layer 4, layer 3, and layer 2. Okay. The third one is phosphatization. This is another phenomenon to have the sedimentary phosphate. And phosphatization is a type of rare genetic process. It occurs when fluids that are rich in phosphates are leached from guano, okay, then concentrated and reprecipitated in limestone. And we have the case of this geological thin section when we can see this phosphatization of the grains. Let's move now to the mineralogy and mineral composition of the phosphorite deposits. So just for your information, that the mineralogy of phosphate deposits is very complex. So we'll try now just to have some underlying information about this mineralogy. And the mineral composition of phosphorite deposits is determined by the phosphate, which is a composite chemical compound of calcium phosphate, calcium fluoride, and calcium carbonates. And phosphate minerals occurring in the primary environments include fluoroapatite, which is found mainly in igneous and metamorphic environments, for example, in carbonatite and the mica pyroxenites, typically in cryptocrystalline masses with the grain size less than 1 micrometers, referred to as what we call in cellophane. The second one is carbonates apatites, or we can call it also carbonate hydroxide apatite, which is found mainly on islands and in caves as a part of bird and bat excrements, what I called already iguana. The third one is hydroxyl apatite, which is found in igneous or metamorphic environments, but also in biogenic deposits, for example, Van deposits. And the last one is froncolite complex. This complex of carbonate substituted apatite is found mainly in marine environments, which is often dissolved from vertebrate bones and the teeth. So here I show some minerals that contain the phosphorus. Let's move now to the genesis of the phosphates. So I apologize because I put this slide at last minute, so I didn't have time to translate it. It is a summary of the process of genesis of the deposits, and it is valid for any type of deposits or minerals concentration. So the first step is the source of the element which has the economical interest, and then we have the natural extraction of this element, then the transfer or transport of the elements, and after we have the accumulation of this element and the preservation. So trying to remember this process because we will apply that to understand how the phosphate, sedimentary phosphate, is formed formed and why we have it connected. So we will work together. If you want, please help me, please, and trying to be interactive because I want that you understand this process and be the ambassador of the phosphate gaze to explain for your colleagues and friends this process. So trying to be interactive, please. So we'll work together to build the genesis model of the phosphates deposits. So I will be sure that you will not forget it. Okay. So we start with the field observation, and we have, and I ask if you have ever seen the composition of the phosphates or never. So does this look like beach sand? Look like this grains here. So we will now go in deeper and into more details, and we will look at these grains into two parts. So, and as we can see here, we have a nucleus, which is in central part, and cortex, which we have here some lamination, and the phosphorus is concentrate in this lamination. Okay. So, so we're trying now I ask the question that please trying to be interactive. Which natural process that can, in your point of view, which can give us this form of grains? It's a very important. You can explain in French, Arabic, English as you want. There's no problem. Okay, we're waiting for some volunteers. Okay, anyone? Okay, so let's go. We were trying to apply the process of the genesis of the deposits, and we will start by source. The very important, the most important element here is the phosphorus, isn't it? So where the phosphorus can come? So we have three sources, three sources. The first one that can be the bones, okay, and that can be also from leaching of rocks. And the third source That can be also ocean from the bridge. So in general, when I ask this question to the participants physically in my conference, the people tell me that that it is due to the death of fish. Generally, when I ask where the phosphates come, they say that it's come from the death of fish and dinosaurs. But by imagine how many dinosaurs and fish that we will have to kill to obtain this huge layer of phosphate. And please, you have ever seen an animal after its death transformed into the grains? It's why we have some other processes that can be introduced in the genesis of this phosphate grains. So yeah, so I said that we have three resources. Now we pass to the extraction of this element. So I said already that from the continent, this extraction come from the lichen, the aquatic lichen or water lichen of this rock. Generally, we talk about Sinite nephelinic, which is a volcano rock. And from the bridge is located at something like 10 kilometers in deep in the oceans. So how we can bring this forest from this deep to the continent? Do you have any idea about that? No answer? Okay, so I can wait for 3 minutes, 3 seconds to have the answer for that. The comment, any comment? So okay, so as I said, that's the magma comes out with the temperature of something like 600 degrees C, and at the surface we have the ambient temperature. Okay, so with the difference in the density of hot water and cold water, we will have the phenomena of convection. Okay, the convection, and now we have to transfer this mass to the continent. And what we will do, so I trying to draw that. Excuse me. Okay, so we have here that. Okay, here we have the ocean, and here we have the magma. Okay, with magma with P. So I say that we have here some convection currents, and as you know, that's the Earth turn around themselves, so it will create what we call in the Coriolis current. So that's help us, and also by the plate tectonics, we have the shape of the ocean which will change it. So we'll have the transfer of this mass from the ocean to the continent, and what's the American call the upwelling currents. The upwelling, so they name this kind of phosphate the upwelling phosphates, and this mass will be transferred to the continent, and it will be trapped here. So we have the P that's come from continents, and another P that's come from the ocean, and we have here some animal activities. Okay, and thanks to God, that's the particularity of Morocco, which is located in this time in the what we call in the passive margin, and we have this obstacle of what we call in the threshold, the threshold, and that's help us to trap water here, which has a high concentration on P, on phosphorus, and we have the regulation of the water. The water it will be trapped here, and by evaporation and the death of different elements, different animals, we have here the concentration of the P and the formation of what we call in gel. And by the bacterial activities, because we have here after regression, we have tertiary element like quartz that's come from the continents, they will weld this lamination around the grains, and we will have our grains, which will be later be distributed in the Gulf. Okay, and to form this huge deposits that we have currently in Morocco and around the world. So let's move now to this is a summary of what I have just presented. So as we can see here, so stemming from the sedimentological, mineralogical, and geochemical composition of the phosphorites, the following conclusion can be drawn regarding the condition of the phosphate accumulation. Here we have some scientific elements because in the other slides, I trying to explain, simplify the model. And here we have some scientific elements. So we have primarily accumulation of phosphates particles. So pure and they're providing a reducing condition together with the enrichment of organic matter. The secondary concentration proceeded by winnowing and the reworking and the oxic condition in a shallow water environment. So diagenetic lithification by carbonates, silicate, and pyrite is characterized here by either reducing or oxidating environment. The fourth one is near surface. In near surface phosphates, rock are generally affected by oxidation of sulfides and organic matter as a consequence of warm, humid, and watering. The last one is the chemical composition of the phosphates rock, which is mainly determined by the reducing condition of primary accumulation. So here we have the different figures that show this process, and I will share with you this presentation if you want. So we talk a lot about the phosphorus, but here we will have some commercial presentation of the phosphate. So we have the phosphorus is, as you know, is an element that is widely distributed in the nature and occurs. So together with the nitrogen and potassium as a primary constituent of the plant and animal life. So P plays a series of functions in the plant's metabolism and is one of the essential nutrients required for plants' growth and development. It has function of structural nature in macroelements such as nucleic acid and energy transfer in metabolic pathway of biosynthesis. And the phosphate is not reduced in the plant, but remains in its highest oxidized form after Marshner in 1993. So the use of the phosphate, so we have something like 5 to 6% used in the feeding, and from 30 to 40% to make fertilizers, and from 66 and to 60 to make phosphoric acid. So I will share here the map that is produced by USGS. This is United States Geological Survey, which shows the geographic location of all of the phosphates deposits and occurrence around the world. And USGS has estimated for Morocco some resource around the 50 billion tons. And we have currently in Morocco access to something like 72.5% of world-known phosphate resources. So in this figure shows the evolution of the price of phosphates that was stable at $40. Okay, but this price was multiplied by 10 between 2007 and 2009 because of the economic crisis during which investors, to protect their money, they invested in phosphates and fertilizers, and thereafter it is the demand and the supply in the market which made a small variation to return a price of $100. And you will see together in details the explication of this volatility in the next course, inshallah. Let's move now with, you know that this is the flag of our country and the logo, and this is the logo of our national pride OCP group that extract and develop the great natural resources, which is the phosphate. So here I want to give you some explication of this logo. So the OCP logo symbolizes a shark teeth. This is a shark teeth. I don't know if you see my screen. This is a shark teeth, what we call it, a lamina obliqua, that are a current fossil in Moroccan phosphates, and this figure is reproduced 5 times, remained in the start of the national flag, and on the other hand, the destinations of our products to the 5 continents. So the set is in a circle around which are placed 2 airs floated in an arc that symbolize the fertility and growth. So OCP Group OCP Group's active mining activity are concentrated in three regions of Morocco, located in 4 mine sites in Khouribga sites. We have there Sidi Daafi, Marah al-Ahras, Sidi Shinnan, and Bni Amir mines, and 3 mines in Guntur Basin. We have there Ben Guerir, Bushan, and Mzinda mines, and 1 in Bukra in south of Morocco. So processing activities of phosphate into phosphoric acid and phosphate fertilizer are essentially concentrated in Jarf al-Asfar and Safi. So let's move now to present you some geological story, or sorry, overview of story of geology at OCP, because I work on that for something like 13 years. So the geological research of phosphates is divided on 3 main phases. The first one is the discovery of phosphates between 1905 and 1921. In 1908, so we had a discovery of the first target of phosphate in Shishawa in internet region by a geologist who was so-called Braves, and this is his presentation of his mom during their travel in Morocco between 1901 and 1907. And in 1917, we have a discovery of the large phosphate basin of Ouled Abdoun, where we have the Khouribga sites. So the second phase is exploration and mining of phosphate deposits. It was between 1921 and 1955, where we had the exploration of area of outcrops of phosphate layers in Moroccan basins. And in 1921, we have the first mining operation in Ouazzam, or in Boujniba, this is in Khouribga site, with the first train of the phosphates to the port of Casablanca. In 1931, we have the first mining operations in Youssoufia, and in 1951, we have the open pit extraction in Sidi Daafi, because before that we had just the underground mining of phosphates. And then we did some stratigraphic position of the main phosphates formation. So we did some studies in lithologic correlation between the main or big basins in Morocco, Ouled Abdoun and Guntur, and we published some memorial devoted to paleontological vertebrates and invertebrates by Arambol. The last phase is the systematic geologic exploration, which starts since 1956, and where we had the geological studies of deposits to meet the requirements of the mining operations, and the systematic geological exploration throughout the 4 main basins of phosphates. And we have also the evolution of chemical analysis protocol, because in the beginning, the quality of the phosphates has defined by 2 chemical elements, and currently we have more than 10 elements to define the quality of the phosphates. And you have also the realization of the sedimentological, geochemical, hydrogeological, and some geophysical and paleontological studies. And we started the digital transformation of geology activities since 2007. So let's move now to see the location of these different basins. So the Moroccan phosphates were deposits between 40 and 70 million years ago. So geologically speaking, between the Maastrichtian, so between Maastrichtian and Lithuanian age, it took some 30 million years plus and minus 5 million years to form this great riches. So these deposits are mainly located in 4 basins in the Atlas area. Here we find Ouled Abdoun. Okay, here we have Ouled Abdoun basin with the Khouribga sites and the Guntur the basin with the Yusufia and Wilgria sites. And in the atlas, we have here Mesqala Basin. And in the south of Morocco, we have here Ouled Abdoul, we call this basin Wad Dahab. Okay. So I note that in addition to these four basins, we have other deposits, but lesser economic importance. We find them in the region of Fez, Ouarzazate, Sousse, and Imishil. Why I say that in Imishil it's not known by the season of marriage, but also by the existence of this kind of phosphates. This is the appetite. So you should know that we have other deposits, but of less importance, and we have not yet studied, and OCP geology still has a lot of work to do in this direction. So let's move now to some details of different basins. We will start by the first one, Ouled Abdoul, which has the area from 10,000 kilometers square with the 50% exploited and studied area. It is the most important deposits where we make the largest production of the phosphates in Morocco. It is limited in the north by the massive central Morocco, and in the south by the plain of Bni Amir, in the east by the Paleozoic massive of Hamna, and in the west by the high atlas of Bni Millah. The area indicated by the color, the brown color, are already exploited, and in gray are being exploited. And the hatched area indicate the future and the future area that we have not yet geologically explored. You can see that since 1920, we have not even explored 10% of the total surface of the basin, and 47% correspond only to the white part. So the figure shows the synthetic stratigraphic log of Ouled Abdoul basin. The phosphate series is composed of alternative phosphates and non-phosphate layers, which we call series or interburden. In the maceration, we have here the layer 3, couche 3, layer 3 to the most important in the Khouribga sites in terms of quantity. In the Danyan and the Tanitian age, we find the layer 2. In the Epresian, we find the most interesting layer on the plants, qualitative and quantitative. It is the layer 1 or couche 1. In addition to layer 1, we find the level and seams, but with the less importance, like layer 0 and seam A and seam B. The whole series is covered by a dolomitic limestone layer, which allows the protection of a large part of the area we are currently exploiting. I note that the naming of layers here that is very specific for each site, but the geological classification is universal. We will see later that the naming is different in other basins. So here just I show you the maceration. As you can see, the layer is not 100% phosphated, but we have an alternation of phosphates and other non-phosphate layers. As you can see on the picture, the text exceeds the 10 meter. So in this picture, we have the continuation of the phosphate series with layer 2 and layer 1 in the equation in the area of the Ghar Tajer located in the west of the Khouribga city. Here it is the east-west correlation section, which shows the thickness evolution of the phosphate layers. We have a reduction in thickness going from the west toward the east. Generally, this evolution is accompanied by an increase in the grade of P2O5. This correlation is justified, but that we cannot generalize it. So we're going now to move to the second basin, which is the basin of Gencho, located at the southwest of the basin of Ouled Abdoul. So it is a basin that extends over than 120 kilometers in length and 25 to 30 kilometers in width. It is divided into 6 deposits or mines. Going from the west to the east, we can find the following deposits: Yusufiya, Bushan, or Luta, Ben Greer, Nzarat Harasha, and Intisat. It is limited to the north by the Paleozoic massif of Rahamna, to the south by Jurassic hills of Misa, to the south by Jbilat, to the west we have the Jurassic hills of Misat, and to the east we have the Tassaut River. So this is the stratigraphic log that shows the different layers identified in this basin, and as you can see, you can notice the number is bigger than Khrivgaz 1. So looking at the evolution of the powers of the thickness with the contents, we notice that the same romax, the layers are thinning toward the haze with the increase of in P2O5 grade, but the remark is not general because we make the case of sim A2 here. We can have here has a big thick, but the grade of P2O5 is very low, and here we have the thickness which increase with the increasing of the grade of P2O5. So here I show some picture, or we can find where we can find the what we call in the landmark layer. This is a Marley clay layer, and with his yellow color, which is very specific and which we can find in whole of the in the basin. And this is the landmark layer. And we have here the phosphates, layer 2 and the layer 3. So here we have the continuity of the different layers, where you can find here the layer 1, which is the more important layer in Ginto. And here we have the layer 1, 2. Just to show you the different layers and the color, the aspect, geological aspect of the different seams and layers that we can find in this basin. So let's move now to the third one, which we call in Mesqala Basin. This basin is located at the foot of the High Atlas in the triangle of Suera, Shishawa, and Imitanut. It is composed of 3 deposits, Ulad Busba, Khamis Mesqala, and Imitanut. It is the basin where we discovered for the first time the phosphates. And it is geologically recognized at 100% and 100%, but the operation has not yet started. So here we have almost the same stratigraphic division at the Gentur Basin with the famous layer of dolomitic limestone, which covered the phosphates. What we can find it here in Lutucian age, and here we have the different age with the phosphates layers. Here we have the layer 1 with some butyration, which is very characteristic in this layer. And here we have some small layers of phosphates, which I call satellite phosphates here in present in Chanut. And let's move now to the south of Morocco, where we have the Wad Dahab Basin. And it is the smallest basin where the phosphates mining take place at exactly Bokras deposits, and it's divided in 9 parts of current and currently the mining operations. We have currently the mining operations, and the operations are located in the north and in the south of the mine. So the notification of the phosphate series is similar than Frida. And the particularity of this basin is that the phosphates are very silicified and rich in chlorine, and the phosphates are covered by a layer of silica instead the limestone cake hamada here in the Bukrasite. So the evolution this time is from the north to the south, going from the south to the north. The phosphate series develops with the increase in the thickness of the layers and the appearance of new layers, like for example here layer 2 and the development of layer 3 when we go into the north. So here this photo shows the operating front of an area of the Bukra mine, when we find here the richest and the most important layer, which we call in layer one, where we started the mining since 1978. So for the mineralogy point of view of Moroccan phosphate, so the main constituent is apatite with this formula, and the associate minerals we can find the carbonate. So in here we can find the dolomite and calcite, the silica represented by the quartz and opal, the clay which is represented by montmorillonite and apapelgite, and the evaporites, but it's very rare to identify. Donc we have there gypsum and some highlights. So for the petrography point of view of Moroccan phosphates, so the figurative elements we already seen that we have there the grains and the bioclast. The ciment generally, this is a carbonate or clay and cellulose, and we can find also other constituents. So like chloride of sodium and organic matter, which can help us to define the light and the dark phases, especially phosphates. So for the geochemistry point of view, so we have the major elements which are the P, calcium, fluoride, magnesium, silicate, and chlor, and so on. And for the trace elements, we can find some chromium, lead, vanadium, thorium, and some rare earth. So now we'll go to see how we explore this huge deposits. So the first step is the data collection. So the systematic geological exploration of the deposit it's done by three kinds of manners. So the first one is wells with a diameter of 0.88 and 1.2 in the shallow phosphate zones. The second, it's mechanical core drilling with a diameter of 0.13 and 0.16 in deep and submerged layers. And we have also the trenches outcrops. So let's see some photo for that, for this methods used in the exploration. And we have wells, as we can see here. And here the geologists who descend into this well to describe the lithology and to get the samples. And we can also use the core draining, as you can see here, and the trenches. And there, this is the gentleman, it's me, but the trench is behind me. And you can see also the vehicles and the cars that we use in the field. So the second step is geological logging and the identification of layer after description in the field. So we draw this geological section as you can see the different color that indicates the layers. And here we have the results of the chemical analysis and description in this part. All of this data are entering in the database or geological information system where we enter in this data. And we have already developed this database on Oracle to have this interactive geological section with the software, what we call the GDM. GDM, this is a geological data management, which is developed by BRGM in France. So by the same software, we can use some new approach like geostatistic to have a good analysis of data. And the interpretation of this data can help us to draw what we call an ISO value maps, or block maps that is used by the operating mining guys in the planification of the extraction. And also we can draw this correlation section, okay, in 2D, and also we can draw the 3D presentation of different deposits. And I will show you here 3D model that I built in 2011, and this is the 3D model of Mzinda deposit. As we can see here in blue, this is the limits of the deposits, and in the white color, this is the boundaries of the panels. And we can see also the description of the different wells located in this mine. And the gray color, this is non-phosphates, and the other color, this is the phosphate layers. Okay. We'll try now to show you the top and the floor of different layers. So here, for example, we have layer 6, layer 5, and layer 4, layer 2. As you can see here, and after, at the end, we have the topography to cover all the layers. And as you can see, this is the interpretation what we done at this time. And here we have this is updated model. This zone are already extracted. And as you can see, we have a good correlation between what we are interpreted in the geology part and what we have in the reality. So let's move now to my last parts of my talk. This is the international standards of resources and reserves, which is led and managed actually by two international organisms. We have CRISCO and UNFC. The CRISCO means the Committee of Mineral Reserves International Reporting Standards, and the UNFC, which means the United Nations Framework Classification. And under the umbrella of CRISCO, we have something like 11 standards. And this standards, they help they help the investor to bring the fund for their mining projects. And in the world, we have in Africa especially, we have just one standard in South Africa, which we call in SAMREC. If not, we have also in Europe, in Russia, in Canada, in E4301, and ISIMI in USA and in Brazil. And recently in Turkish, we have the Turkey IMREC. This is a new standard which is attached to CRISCO. And we try in Morocco, we're discussing currently to see with the colleagues in the ministry how we can also develop our own standard. So let's move now to my last slide. It's the resources and reserve definition. I don't know if we can give me the definition of the resource, because it's very important. Are there any volunteer for that? Mineral resource. No one? Okay, so the mineral resource is a concentration or occurrence of solid material of economic interest in or on the Earth's crust in each form, so grade or quality, and the quantity that there are reasonable prospects for eventual economic extraction, the location, quantity, grade or quality, continuity, and other geological characteristics of a mineral resource are now estimated or interpreted from specific geological evidence and knowledge, including sampling. Mineral resources are subdivided in order of increasing geological confidence into three classes: infrared, indicated, and measured categories. And the reserves is the economically minable part of measured and indicated mineral resources. This is a standard definition that we have to know. It includes deleting materials and allowance for loss, which may occur when the materials is mined or extracted, and is defined by studies at pre-feasibility or feasibility level. Because we have already the conceptual study when we have to study the resources. And such studies demonstrated that at the time of reporting, extraction could reasonably be justified. So I can present this like this shape. So we have the resources and we have a reserve, which is a part of a resources. And this is a standard classification of the different category of the resources and the reserves. So my talk is finished, and thank you very much for you and for my colleague Salim Adinawi. The floor is yours, Dr. Salim or Dr. Nawi. Thank you.
Yes, thank you, Professor Youssef Daafi, for your, of course, wonderful lecture, and it has a lot of information that maybe most of us who attend here, they want to gain more knowledge and information. For that, maybe they are silent. But anyhow, sometimes it happens like that. We need to listen. We need to be careful about what we are going to say, and we let the lecturer to explain all the things. I think also you provide us with a video. I think if it is possible that we put it now also, so just maybe it can clarify some of the information also. Let me share it, please. Okay, it is there. It's about the UM6P vision short. So let me go for it. Share screen. And close the. Okay. Let me raise the sound. Maybe it can be better also. Yes. Let's go on.
In 2017, a new research and innovation university was inaugurated here in Morocco. Designed from the outset to be an ecosystem for innovation, research, and entrepreneurship. The first of its kind to be built in Africa. A next-generation university with 5 founding principles. Promoting research, innovation, and entrepreneurship. Developing skills and knowledge. Bringing forth a new generation of competent leaders. Developing sustainable partnerships. Sharing the values of social responsibility and sustainable development. Attracting many of the best minds from Africa and across the world to its main campus here in Ben Guir, 50 kilometers from Marrakesh. Mohammed VI Polytechnic University has a forward-looking approach to research and education, fully focused on innovation, experimentation, and the pursuit of excellence, with an ethos of learning by doing. PhD students and professors work together as part of a unique entrepreneurial culture, developing pertinent research projects critical to helping Africa realize its potential, with experimentation at the heart of education, starting research in small laboratories before scaling up to full-size experimentation in our living labs. Such as the experimental farms to test new methods in agriculture and fertilization. Making ideas grow and incubate in the innovation and entrepreneurship platform with a network of mentors, coaches, and numerous scale-up opportunities. Tackling the challenges of education in Africa is a core principle of the university by being close to policymakers while being anchored in academic analysis and knowledge. The university focuses on bringing concrete answers to the population's needs. The Digital Learning Lab develops digital modes of education, including massive open online courses, widening the reach of education and knowledge. The university aims to bring forth a new generation of environmentally conscious, competent leaders, offering scholarships to the best students from remote areas, being socially inclusive, giving a chance to everybody to succeed. The university is connected to a global network of academic and research institutions, while also developing partnerships with public institutions and industry, collaborating in R&D, continuous education, and knowledge transfer. Revitalizing agriculture in Africa is a challenge not only for the people of Africa, but for the people of an ever-growing world. By bringing humanities and technology sciences to the continent, and by educating the next generation of competent leaders, Mohammed VI Polytechnic University brings a solid contribution to Africa's sustainable development. Mohammed VI Polytechnic University, nurturing today's talent, impacting tomorrow's Africa.
Thank you.
Thank you very much.
Have any comments that you want to give?
If you allowed me, I can present a little bit in Arabic like I did every time.
Okay, go ahead, Professor Ahmed.
Okay, thank you. Do you see my slide?
Yes, it is.
Okay. So أولا أشكر السيد سالم من جديد لأنه دائما معنا ويأخذ كل شيء عن جد ويسهر على كل شيء. أشكره جزيل الشكر من السبايك من المملكة البحرين. الأستاذ يوسف دافي أشكركم جزيل الشكر. أنتم أستاذ بجامعة محمد السادس بوليتكنيك، والآن نظرنا إلى لمحة عن بوليتكنيك. تحدثتم عن الآفاق الحالية والمستقبلية لتقنية النانو في أداء أنظمة الطاقة الشمسية. عفوا، كتبت يعني عنوان آخر، أنا آسف. سأخذ أعطوني 1 second please. Now I'm in. تحدثتم عن كل ما هو يعني له علاقة بالجيولوجيا في المغرب، وقناعتي بالنسبة إلينا في Virtual Learning University هو أن الدورات الأكاديمية من الدورات الأكاديمية الأساسية للجامعة التركيز على الدراسات الجيولوجية والجيوكيميائية والجيوفيزيائية والاستكشاف أو الاستكشافات الجيولوجية واستعمال علوم الحاسوب لتطوير الخرائط الجيولوجية. وأنتم قد تحدثتم، قد استعملتم بدون شك الحاسوب لتطوير الخرائط الجيولوجية وتطوير العلوم والتقنيات لتحديد موقع الموارد الطبيعية والخامات وكميتها وكيف سيتم استثمارها. هذه الثروات الطبيعية من معادن ذات قيمة صناعية واقتصادية عن طريق التصنيع ابتداء من المواد الخام أو المواد الأولية وتحويلها إلى منتوجات نهائية قابلة للتسويق ذات القيمة المضافة الخاصة وبطريقة مستدامة تحترم البيئة مع الأخذ في الاعتبار على محمل الجد للحصول على خبرة دقيقة متاحة لصناع القرار السياسي وليتم دمجها في خطة مستقبل بلادنا لخلق الثروة وفرص الشغل. وهذا هو الأساس في نظري. نحن محظوظون بوجودكم السيد يوسف من جامعة محمد السادس بوليتكنيك ومسؤول في مكتب نقل التكنولوجيا مهندس جيولوجي، تخرج من المدرسة الوطنية العليا للمناجم بالرباط، ماجستير من جامعة القاضي عياض في علم المعادن، شهادة كلية كولورادو للمناجم لتعدين الفوسفات، ماجستير من أرقى المدارس الكبرى في باريس في الجغرافيا السياسية والاقتصادية لإفريقيا الناشئة. له اهتمام طويل الأمد وخبرات فنية متنوعة في قطاع التعدين. أشكركم جزيل الشكر، ومن طبيعة الحال سأعطي الكلمة للسيد سالم حتى يتيح للحضور يعني الافتراضي الفرصة لكي يضعوا أسئلتهم، وشكرا لكم.
شكرا بروفيسور أحمد. الآن نفتح باب الأسئلة والمداخلات. Any questions or comments that you want to add, please, the floor it is open for everybody. بالإمكان برفع الأيدي by raising your hands, or you can write in the chat your questions, and we are waiting for you. Yes, Professor Ahmed Rasili, please.
I need, yeah, okay, it's active now. Thank you so much.
Yeah,
so, Professor Daafi, I was a little bit late to attend your presentation from the beginning. I had another meeting, so I'm happy to be here. I listened to your conclusion and the last minutes of your presentation. Just would like to mention that I was born in Boullanoir. I don't know if Boullanoir means something for you. This is the first phosphate mine in Morocco. It start being exploited on 1923, and I was born just in front of this. Not in 1923. I was born in later on. But just in front of this first mine that was opened in Morocco. I just one small question. I also like your last slide with the definition of resources, mineral resources and ore resources, and I will copy this from you just to illustrate. I will treat resources in my presentation on the next Tuesday. I will speak about resources and the scarcity of resources, and the resources are not limited. So yeah, definitely the ore and the mineral resources have a limit. The quantities are limited, are well known within the earth, and we need definitely to manage this kind of resources for the future generation. Can you please just tell us? I don't know if you mentioned it already in your presentation. What is the still available as a resources in terms of phosphate in Morocco?
Yes, I already said that currently the USGS, United States Geological Survey, has talked about something like 15 billion tons. This is a resources.
Resources, yes, not the ore.
It's why I gave this definition of resources and reserves.
Yeah.
So in terms of the resources, we have 15 billion tons, and since 1920 until now, I think that we are extracting like something like less than 10%.
Yeah,
it's a very huge, huge base and very huge deposits. And we have still a lot of phosphates in Morocco.
Yeah, but it's becoming difficult to extract phosphate, because we used to have this near surface and the deepest one. It's not. There's only one. Yeah.
Yes,
there are many layers.
It's become difficult, yes, but we don't forget that we have also the university which is here to bring the new technology to extract efficiently this resources.
Yeah.
So yes, it's difficult because we have a high recovery of this phosphates, but we developed in parallel the technologies, the mining technologies to use in the extraction of these resources.
Thank you so much, and congratulations for the night. Thank you.
Thank you, Professor Ahmed Rasili. Any other questions or comments, please? Okay, Prof. Ahmed, you want to say something?
Yes. I want to, I know that Morocco has his own satellite. I don't know the name. It's like Mohammed Sis satellite or something like this. Anyway,
Mohammed Sisi, Mohammed.
yes. And do you is it use it to explore the remining or the mines in Morocco, or in general, how do you, what are the tools you have to work to explore the mines in Morocco?
So yes, Dr. Nawi, this is a very important question because currently we talk about the remote sensing, and the remote sensing we use the image satellite images to, in the beginning of the geological exploration, what we call in the green fields, to detect and delimit the what we call an anomaly. So the zone when we have the high concentration of the elements, and we use this image and we analyze this image to define and delimit these zones. Yes, we use it. We use it a lot. This the satellite data. And when the satellites get more the precision is higher in the image, more the information is precise, and we have a good information to use to decide in if the zones can contain a good mine or not. Says yes, we use it. Yeah.
Okay. Another question is, which is a little bit political. I know that we have a lot of mineral, a lot of mines in Morocco. Phosphate is one of the big one. Do we have any industry which move from raw material, but Moroccan industry, of course, I'm talking, to to give a value of this mine, anyone, or we just sell our patrimoine, our resources, just a raw material? Do we have industry? Do we gain
So
something?
let's say that for the phosphates, where Morocco extract the huge, the big, the big quantity of mining substances, all of the rocks. So let's say that until 80% of the rocks is transformed locally in Safi and geoplasma, and we transform the phosphate rock to the acid, phosphoric acid, and the fertilizers. So here we have this added value that we gave on our raw materials. But for the other elements, yes, we don't have any industry to transform this metals, and we export the raw material directly.
Okay.
Really few quantity which is used locally.
Well, there are many questions in this area. For example, in phosphate, do we have some rare element which are used in electronic and which is extremely important? Do we have some? How much is a ppm or microgram? And do we have method to extract it? This one.
The rare earth we have it. We have it, the heavy rare earth in phosphates, and so we did a lot of analysis on our on different layers, and we have these elements. But until now, I think that's the colleague at the university. They work on the uses and extraction of this rare element. And if one of the colleagues here in the VLU has the technology to help us to extract and evaluate these elements, he will come with us. Yes, we're working still on this technology.
You spoke about rare elements or rare earths?
Rare earth elements.
No, rare earth. I talk
Okay.
about rare earth. The one you find in iPhone, in some very specific compound in devices.
You know what? We have all the elements in the PDF table are present in the phosphate ore. All the elements.
Thank you, Prof. Ahmed. let's see if there is any other questions. Okay, yes, we have Prof. I cannot.
Mucho Zoraya.
الموتشو
الموتشو
سوريا.
الموتشو Soraya. Okay, please.
Go ahead.
You can start, please.
Hello everyone.
Hello.
Can you hear me?
Yes.
My name is Soraya Mucho. I have my master's degree from M6P in field of chemical science and valorization of natural phosphate. First of all, I will thank you very much, Mr. Daafi Youssef, for this great presentation, and also professors Mr. Nawi and Mr. Salim for this e-learning university. My question is about the black phosphorus. Do we extract it here from in Morocco, and which process we use to extract it? It is the same process for the white phosphate.
Okay, so for the dark or light phosphates, it's what we call them. So we call it light and dark. It depends of the grade of carbon, organic carbon, but it has the same geological criteria. So it's the same layer. It's just in the dark layer, we have more a conservation of organic matter, why the color is dark. And the light one, there we have with the oxidation, so we have the departure of the organic carbon. This is the difference.
Okay. Thank you, Professor.
You're welcome.
Thank you, Mr. Rayo. Any other questions, please? Okay. I think if there is no any other questions, you can give us, you can conclude your lecture, Professor Youssef. What you want to say at the end?
So I would like to thank all the attendees for the time, and I hope see them for my next courses with more interactivity, because it's very interesting for me. So thank you very much for your time, and thank you very much, Professor Nawi, Mr. Salim, and the colleagues and friends of ALU, and see you maybe the next season for my lecture. Thank you very much.
Thank you, Professor.
I think there is a question from Abdel Wahid Shari.
Okay, good.
Abdel Wahid, okay. Please, Abdel Wahid, he wants to talk straight. Yes, go ahead. It is open. You can, the mic it is open. You can have your question, please, or comments.
Thank you so much. I have just a comment to Professor and my friend Youssef Daafi. I would like to thank you a lot for this talk, and I hope you all the best in the future. Thank you so much.
Thank you.
Thank you. Right. وصلنا الختام. الكلمة لك Professor Ahmed. Please welcome.
Thank you very much. I will come back to this before we miss some few things, but I was a little bit not very. So first of all, I want to correct before what I say is that in Arabic we are talking about رواسب الفوسفات المغربية التكوين وطريقة الاستكشاف. That's what I missed. That's one thing. The second thing, I think Ustad Salim, he says that many times, that we have now a web page, what you see here in the front of you. I will use the laser here to show it. So we have a web page, so you can go on, and you can also chat with us in Instagram. So if you have Instagram yourself, you can we are on Instagram, and you can see a lot of things in Instagram, YouTube, All our material will be broadcasted on YouTube. Our email address, if you want to contact us, and anyway, through the web page, after some weeks, we'll be completely ready to chat with us, to talk to experts, etc. So please, that's the philosophy of virtual learning university, is to stay together in contact, and the student can contact the professor and vice versa. So, and I want to thank Professor Daafi for this talk, and I think if any student want to know about resources in Morocco, mineral resources, and any detail, we have expert at the Virtual Learning University. I want also to thank again Ustad Salim for being always with us, for making everything working good. I know it's hard, but we are making a lot of progress. Thank you very much.
Thank you to you, Prof. Ahmed. So, and we'll inshallah meet you in the next lecture, which is going to be tomorrow. Can you present the information for the?
I have to find it in my file, or if you have it, you can also show it.
Okay, let me also check. Okay, for yes. For day 6, you can go ahead with it, Professor Ahmed. It is.
You have it.
Yes, you can go ahead.
Cool. Yes. Okay. So it will be Dr. Jawad Al-Kharraz. He's actually executive director in the regional center for renewable energy in Egypt. He's Moroccan, and he just got a very huge job in the regional center, and he will talk about sustainable desalination technology. So he's an expert on the desalination of water, of seawater, and also other kind of water, and he will talk about this topic. It's a very important topic for Morocco, for the Middle East, for Africa. So try to be with us, and I'm sure he will give you a lot of information. So I will, of course, we will make it on the Facebook and everywhere that you can see. And the link to the conference is always the same, I guess. So thank you very much.
So thank you. See you tomorrow at 2 p.m. Moroccan time.
Thank you very much.
Thank you. Masalam.
Thanks all of you. Salam.
Masalam.